Hello guys, and welcome back to our YouTube channel. In this video we are going to solve a question under the inverse of functions. Okay, so the question says f of x is equal to 6x minus 5 and we should find the inverse of f of x. Okay, there are three things in finding the inverse of a function. First, we need to test if f is injective. Yes, we need to test if f is injective. Remember, another name for an injective function is a one-to-one function. So we need to test if f is injective. That is the first case. Secondly, we need to write the function y equals to f of x and solve for x. And thirdly, we need to check if the domain of f is the range of f inverse. So we need to check if the domain of f is equal to the range of f inverse. Okay, so those are the steps. So let us start. So let's take the first step to test if f is injective. For injectivity of functions, f of x1 should be equal to f of x2. That is, x1 should be equal to x2. Okay, so we are going to see how to do that. So f of x is equal to 6x minus 5. So firstly, let's find f of x1. It is just simply 6x1 minus 5. And f of x2 is simply 6x2 minus 5. Okay, so we need to equate these two and see if we are going to end up with x1 equal to x2. So if we end up with x1 equal to x2, then we can say that f of x is injective or is a one-to-one function. So let's start. We have 6x1 minus 5 equal to 6x2 minus 5. Okay, so from what we see here already, we can see that these two will cancel out. Why would they cancel out? If we send this way, we are going to have 6x1 minus 5. When we send it this way, its sign changes to positive, and that is plus 5 equal to 6x2. So this gives us 0. So we can send it out. So we are going to be left with 6x1 equal to 6x2. Okay, so now we can divide both sides by 6. Divide both sides by 6 and it will cancel. So we will be left with x1 equal to x2. Okay, so now that we have proven that f of x is injective, because this shows that f of x is injective, so since we have proven that f of x is injective, then we can go ahead and find the inverse. Remember, only one-to-one functions have inverses, so let's not forget that only injective functions have inverses. So we need to first of all know whether it is injective before we find its inverse. Okay, so now that we know that it is injective, we can go ahead to the second step. The second step says we should write y equal to f of x and solve for x. So we are going to say y, so this is step 2, y equal to f of x. So that will be y equal to 6x minus 5. So here we are going to solve for x. So from here, as we can see, we can send this way. So you would have y plus 5 equal to 6x. Okay, so let me just reverse this. It's going to be the same thing. 6x equal to y plus 5. Okay, so since we are solving for x, we are going to divide both sides by 6. So we will divide both sides by 6. This will cancel and we will be left with x equal to y plus 5 on 6. Okay, so from there we can state our inverse. We can say f inverse of x is equal to, so here we are going to replace y with x everywhere. So we are going to replace this, we are going to replace y there with x. So you will have x plus 5 divided by 6. So this is our f inverse of x. Okay, so that is the second step. And the third step says the domain of f should be equal to the range of f inverse of x. Okay, from here we can see that what is the domain of f? F of x is simply 6x minus 5. So the domain of f is simply x, an element of real numbers, because here since f of x, we have f of x equal to 6x plus 5. Here the denominator is 1 and 1 is a real number, so we have only 1 in our denominator. So we will just say that the domain of f is x, an element of real numbers. And as we can see our f inverse here, our f inverse, the denominator is 6. 6 is also a real number. So the range and domain of f and f inverse consists of all real numbers. So from here, that was our third step. So we have concluded that the domain and the range of f and f inverse consists of all real numbers. So that is what we have. So that's all for today, guys. Thanks for watching this video, and I'll see you guys in the next video.